So at Husk Power Systems, we build, operate, and maintain mini grids across two continents, India and Nigeria, as we speak today. And we are serving 300 communities and growing at a pace of about 25 new systems per month. What that means is we are scaling up quite fast and adding a whole lot of new customers on a daily or a monthly basis. How do you truly scale from, let's say, when we had 100 systems to now 300 systems, and we are targeting 1,400 systems as you were introducing me in the beginning? How do we really do that in a profitable way and not overwhelm the management of these systems and lose the benefits that we want to bring to our end customers? So that was the problem that we were trying to think of solving. And we figured predictive AI, that is what we use today, to solve the problem of running all these assets that we now have across two continents in a way that is much more automated, less human dependent, and therefore we don't need sort of rocket scientists to fix or address the operational challenges that we might be facing in one of the remote villages in Nigeria today, right? So we attacked, or we brought AI to the mix of this asset management by thinking what is the scaling problem that we have and how best to address it so that we can bring this renewable energy that we want to bring to end customers at a very affordable price point. And so so the actual use case is, we looked at the data that we had collected on energy consumption pattern of different customer segments across India and Nigeria, and they have different customer segments and different energy consumption pattern. We then started applying principles of predictive AI. By the way, we started using AI before AI became cool. After OpenAI just blasted AI around the world. We were doing it in 2018, 2019 before AI was considered quite cool. So that was the genesis of bringing predictive AI to the equation of managing multiple assets in a profitable way so that we can scale very rapidly from 10 systems to now we are targeting 5,000 systems by 2030, while delivering close to 100% renewable energy to our end customers. And there are some unintended consequences of using AI. In the example that I'm going to cite is a positive one. So we do use a hybrid mini grid system that uses solar PV for daytime supply. We use battery. And in Nigeria, we are using a diesel generator as a second source of energy. And in order for us to meet 24/7 across multiple seasons, we were using 10 to 12% of our energy mix that came from diesel. When we launched the AI program, we did not think that we will be able to reduce the diesel energy mix, but we were. So unintended consequence of the program that we built reduced the diesel consumption by half, right? So it absolutely reduced my cost of operation, but most importantly, it actually reduced the carbon footprint and brought our renewable energy mix to 95% from 90%. So I'll stop there. So that's our use case, and that has helped us scale quite rapidly in an economically positive way, and we're able to pass the cost advantage and climate benefit to this planet and people.
Manoj, I don't know if you can briefly just say give us an idea of how AI helped you achieve that reduction in diesel usage?
Yeah, so what we are doing is we are predicting the uses of electricity by different customer segment at different time of the day. So, prior to AI, we were using manual process. So our engineering team will figure out what should we be running at any given point in time to serve the demand of electricity that exists at that given moment. And not knowing every parameter, the manual process of optimizing electricity output resulted in overutilization of diesel generator as an asset that we have as a secondary source of energy. When we started using AI, it actually maximized the uses of solar PV electricity that was generated to make sure that the battery is always charged to the full capacity. And if we have, let's say, rain predicted for the next 1 hour or two. It will not automatically fire the diesel genset, which in manual process our engineering team actually will or would have. And instead, it will actually maximize the renewable energy consumption by tapping from the battery source. So this is a simple, very simple example of how AI optimized better than what our engineering team could do prior to 2020 using the manual process that we used to have.